how Earth's location was found in the Milky Way. Sit back, relax, let yourself listen in on this 3-hour relaxing science stories. Imagine the world before cities, before ships, before the very idea of science had been shaped. There are no electric lamps, no glow of neon, no satellites streaking overhead. The night is absolute. When the first humans looked up, they saw a sky unbroken by light pollution, vast and alive with pinpricks of fire. The darkness was never truly dark, for the stars poured down with a clarity we can hardly imagine today. The band of the Milky Way stretched from horizon to horizon, thick with light so dense it looked like smoke, like a river of pale fire poured across the heavens. Those early eyes did not yet know about galaxies or black holes, but they knew awe. They knew that something immense and unexplainable loomed above, and they gave it stories to make it bearable. The first stargazers were not astronomers but survivors, hunters, gatherers, wanderers of plains and forests. They had no telescopes, no equations, but they had curiosity. Around their fires they spoke of the stars as ancestors, spirits, beasts and gods. The Milky Way, so striking it could not be ignored, became a road for souls, a trail for heroes, or the milk of a divine mother spilled across the sky. In different lands it carried different names, but in every culture it was noticed. Nobody could mistake it. It was a scar of brilliance on the night, proof that the heavens were more than scattered stars. They had a structure, a shape, a story. For ancient people, the night sky was more than beauty. It was a calendar, a compass, a warning. The phases of the moon marked time. The rising and setting of constellations marked seasons. Migration of animals, floods of rivers, the right moment to plant or harvest, these were tied to patterns of stars. And woven through it all was the Milky Way, steady, permanent, a backdrop to the cycles of life. To gaze upward was to see not just random points of light, but an order that suggested meaning. In the dark silence under that spray of white fire, early humans felt the universe pressing close, mysterious and eternal. As centuries passed, myths thickened around the stars. In Greece, poets said the Milky Way was milk from the breast of Hera, spilled across the sky when she pulled away from the infant Heracles. In India, it was a celestial river, the Ganges flowing through heaven. In the Americas, it was the path of spirits, guiding the dead to their resting place. In Africa, it was ashes from fires set by the gods. Everywhere, humans looked up and tried to place themselves within it. The Milky Way became a storybook written in light, each civilization reading it differently, each generation adding new chapters. But beneath the stories lay the same mystery. What was it really? To the eye, the Milky Way seemed both near and far, both solid and smoke. Its edges were sharp, but its body was hazy, as though the sky itself had been brushed with a painter's hand. No lion roared, no mammoth stamped. The stars gave no sound, no touch, no smell. And yet, they pulled the imagination stronger than any earthly thing. It was terror and comfort at once, for to look at that endless spray of stars was to realize how small the fire at your feet really was. The night pressed down with a weight beyond comprehension, and the only shield against it was story. The earliest astronomers left no written equations, but they left monuments. Stone circles in Africa, in Europe, in Asia, aligned with solstices and star paths. Megaliths marking the rising of Sirius, pyramids aligned with Orion's belt, petroglyphs that trace constellations. Long before Galileo lifted a telescope, humans had already begun measuring the sky with their eyes and their stones. They may not have known the word galaxy, but they knew there was a pattern. The Milky Way was their map, their backdrop, the canvas upon which time itself was drawn. And in the quiet of those ancient nights, something more happened. Humans began to wonder if the stars were not just lights, but worlds. Some myths imagined the stars as fires of gods, others as holes in the fabric of heaven. The Milky Way itself became a highway, a migration of celestial animals, a gathering of spirits. These myths, though poetic, carried an insight that would one day prove true, that the Milky Way was not a cloud, but countless stars, so many they blurred into a continuous glow. Without tools, without science, humans sensed the truth. The galaxy was a community of suns. Consider the power of such perception. Our ancestors had no microscopes, no physics, but they had time and eyes and memory. Night after night, they studied the heavens until the patterns became familiar. The hunter's belt, the bear's back, the river of stars, they were etched into memory. To be human was to be a creature of the sky, as much as of the earth. The Milky Way reminded them they were part of something vast, something beyond their small fires and fragile shelters. It was terrifying in its immensity, comforting in its constancy. This first chapter of discovery is not about mathematics or telescopes. It is about awe, about the moment when humans recognized the sky as more than decoration. The Milky Way was a cosmic fingerprint, a mark that set the heavens apart as structured, alive, meaningful. Even unnamed, it commanded reverence. It taught early humans to measure, to record, to remember. It pushed them to ask, where are we in all this light? And that question, asked by shepherds on hillsides, sailors at sea, storytellers by firelight, echoed across millennia. To find Earth's place in the Milky Way, to answer the question of location, we first had to recognize that we were inside something at all. That recognition began with naked eyes and myths of rivers, hunters and gods. It began with awe, the oldest science of all. When night falls and the horizon softens into darkness, the sky blooms with ancient light. Across its dome runs a hazy band, brighter than clouds, softer than smoke, glowing like something spilled from a hand unseen. For thousands of years before science gave it the name Milky Way galaxy, civilizations looked up at this glowing streak and named it through story. They did not see distant stars bound by gravity into a spiral of unimaginable size. They saw what their hearts and imaginations could grasp: milk, fire, rivers, pathways, spirit roads. The Milky Way was not just a sight in the heavens, it was a story woven into culture, religion, and survival. It became one of the most important canvases for human meaning, long before the first telescope revealed its true nature. In Greece, the myth was vivid. They imagined the goddess Hera, startled when the infant Heracles nursed at her breast, pulling away in pain and surprise. Her milk spilled upward, splashing across the night to leave the trail of pale white we still see. To them, this shimmering band was divine essence, life-giving nourishment, spread across the stars themselves. The Milky Way became proof that gods walked close to the world, their actions echoing forever in the heavens. To look up was to remember that divine power and human fate were never separate. The very nourishment of the gods was now fixed in the night sky. Other cultures made it a river. In India, the band of light was seen as the heavenly Ganges, a mirror of the sacred river flowing on earth. Pilgrims walking the riverbanks knew that their journey reflected a greater cosmic path traced in the heavens above. For them, the stars of the Milky Way were not scattered, but joined, a celestial current carrying souls and deities alike. In Mesoamerica, the Mayans saw the same band as the world tree, the saber tree whose roots pierced the underworld, whose branches reached heaven, and whose trunk was the Milky Way itself. In this vision, the glowing band was not only a place but a connection, uniting the realms of life, death, and spirit. The Navajo called it the Holy Wind, a pathway of creation itself. They saw it as the ashes of campfires left by holy beings, or as a trail across which spirits walked into the afterlife. In South Africa, the Khoisan people imagined it as the scattering of wood ash across the heavens by a girl who wanted to bring light to the night. In Finland, it was the path of migrating birds, a celestial road marking the way north and south. In each culture, the Milky Way became both map and myth, guidance for the living and hope for the dead. Even in its names, the imagery lingers. Via Lactea in Latin, the road of milk. In Chinese, it was the Silver River, a luminous stream separating the heavenly lovers Niulang and Jinu, who could only cross it once a year on the 7th day of the 7th month. Lovers on earth told their own stories by this cosmic light, knowing their yearning mirrored the eternal drama painted in the sky. In cultures scattered across continents, the Milky Way became the bridge between realms, a road walked by spirits, gods, lovers, and ancestors alike. The importance of these myths lies not only in their poetry, but in what they reveal about humanity's relationship with the cosmos. The Milky Way is unmistakable, a feature that dominates any dark night sky. Ancient civilizations lived without modern distractions, without light pollution, without barriers between themselves and the stars. The band was visible to everyone, from shepherds watching flocks to sailors navigating seas. It demanded explanation, and in the absence of science, the human mind filled it with meaning. These stories were not simple decoration. They were ways of embedding the sky into daily life, of turning the incomprehensible into something intimate and familiar. The Milky Way was also practical. Its band helped mark directions, stretching roughly along the galactic plane. Travelers and nomads used its glow as a compass, orienting themselves on open plains or seas. Its appearance shifted with the seasons, giving clues about the time of year. Myths grew in tandem with these observations. To say it was a pathway for spirits was also to say it was a pathway for people, guiding the living, just as it guided the dead. Astronomy and mythology were never separate in these early times. They were two sides of the same need to make sense of a sky that ruled survival. Imagine the awe of those ancient watchers. Without telescopes, they still understood that the Milky Way was different from the scattered constellations. It was dense, continuous, a flood of light made of countless sparks too small to distinguish. In its glow, they sensed vastness, an immensity that dwarfed their lives. They did not know the word galaxy, but they knew they were standing under something immeasurable. Their stories reflect both reverence and fear, the fear of being small, the reverence of belonging to something larger than the earth beneath their feet. In the myths, we see glimpses of truth. The Greeks imagined spilled milk, scattered in droplets. What is the Milky Way if not scattered stars, countless drops of light pooling together? The Mayans imagined a tree binding realms. What is the galaxy, if not a structure binding stars, planets, and gas in a single trunk-like spiral? The Indians imagined a river, a flowing stream of light, not solid, not still, but dynamic, just as we now know the galaxy is alive with motion. Even when wrapped in divine story, the metaphors echoed something real, that the Milky Way was not a simple streak of brightness, but a system, a structure, a whole. The river of milk became a mirror for human culture. Each civilization projected its values, its fears, its hopes into the stars. For some, it was nourishment, for others a pathway, for others a warning or a promise. Yet the common thread was this. It was always more than a sight. It was a sign. It told people they were part of a universe larger than their horizon, that their lives were threads in a pattern they could not fully see. Over millennia, as science grew, these myths did not vanish. They lingered in language, in poetry, in memory. Even today we call our home the Milky Way, a name that carries hearers' spilled milk as much as it carries astronomical precision. The stories remain alive because they capture something science cannot replace. The feeling of standing under the night sky and knowing it holds secrets beyond comprehension. Before equations and telescopes, the river of milk was our first attempt to locate ourselves, not in mathematics, but in meaning. And this meaning mattered. It gave courage to travelers in deserts, hope to mourners by graves, wonder to children staring upward. It gave people a sense that the universe was not chaos, but connection. To believe that your soul would walk the Milky Way after death, or that your God's milk blazed across the heavens, was to believe you belonged, and belonging was survival. This is the foundation upon which science would later build. To find Earth's true place in the Milky Way, astronomers would need telescopes, mathematics, and centuries of observation. But before that, humanity needed to believe that the Milky Way was something to be understood. The river of milk gave them that belief. It turned the galaxy into something close, something human. And in making it human, it made it unforgettable. To stand in the dark today, far from city lights, and see the Milky Way arch overhead is to see what our ancestors saw. It is to glimpse the same band of light that inspired Hera's myth, the Mayan world tree, the Indian river, the Navajo pathway of souls. We carry those myths within us, even if we call it by scientific names. They are reminders that the galaxy is not only a collection of stars, but also a mirror of humanity. It has always been more than light. It has always been story. And the first step in locating Earth within it was simply naming it, giving the river of milk a place in human imagination before science gave it a place in the universe. In the age of Aristotle, the world was still small, bound by the Mediterranean and the imagination of a few civilizations clustered around it. Yet the sky above was immense, unavoidable, an eternal theatre of stars. The Milky Way stretched across it as always, glowing faint and steady, too diffuse to be called a constellation, too obvious to be ignored. For centuries, it had been the milk of gods, the river of souls, the smoke of divine fire. But now philosophers began to shift from story to speculation. The myths did not vanish, but alongside them grew another way of thinking, the urge to explain the heavens in terms of nature itself. It was here, in the world of Aristotle's dome, that the first theories of the Milky Way's physical nature took shape. Aristotle, one of the most influential thinkers of his age, believed the heavens were perfect. The stars, planets, and moon were fixed in crystalline spheres, transparent shells encircling Earth. Beyond them lay the realm of the divine, untouched by corruption, decay, or change. The Milky Way, to Aristotle, could not simply be another collection of stars. In his Meteorologica, he suggested it was a phenomenon of the atmosphere, vapors rising from the Earth, igniting at great height, shimmering faintly like celestial fire. To him, it was not a river of gods or souls, but a natural effect, closer to the play of light than to divine milk. It was philosophy leaning towards science, though still bound by limited observation. The Greek world was not united in this interpretation. Democritus, centuries earlier, had whispered a radical thought. The Milky Way might be composed of countless distant stars, so far away that their light blurred together into a haze. Without telescopes, he could not prove it, but his guess was astonishingly close to the truth. Still, Aristotle's authority carried greater weight, and for centuries his vision dominated. Spheres, perfection, and an Earth at the unmoving center of it all. The Milky Way was a curiosity, yes, but one framed within a system where everything revolved around us. The Romans inherited these ideas, building upon Greek philosophy while still keeping myth alive. Writers like Cicero described the Milky Way as a celestial path, a road of the gods, yet also entertained Aristotle's naturalistic theories. To them, as to many ancients, myth and philosophy could coexist. The dome of the heavens was fixed, eternal, but the band of light across it invited questions. Was it fire? Was it divine substance? Or was it something farther, stranger, more numerous than eyes could count? These early thinkers lacked instruments, but they had logic, and they had the skies. The Greeks built armillary spheres, rings of bronze that modelled the heavens. They watched the paths of stars and planets with meticulous care. And though the Milky Way did not shift like a wandering planet, its fixed presence begged for explanation. In Aristotle's model, it was atmospheric fire. In others, it was the friction of celestial spheres, the rubbing of crystalline shells generating light. In still others, it was exhalations of the stars themselves, a residue of heavenly breath. None of these were correct, but all revealed something vital. The Milky Way had become not only a myth, but a problem to solve. The philosophical shift was profound. To imagine the Milky Way as natural rather than purely divine was to open the door for later astronomy. It meant the heavens could be questioned, studied, described. The myths gave meaning, but philosophy began to give method, and though the dome of spheres would later collapse under the weight of evidence, it carried humanity forward for centuries, giving structure to thought about the cosmos. The dome itself was part of the terror and the comfort. For the Greeks, to live under crystalline spheres was to live in a universe both finite and ordered. The stars were not infinite. They were fixed in a shell, turning predictably. The Milky Way was not chaos. It was part of that order, even if misunderstood. In this worldview, Earth was the center, humanity the focus, and the heavens a dome enclosing us with perfection. It was comforting to believe the cosmos had limits, that it was knowable, structured, purposeful, and yet there was always unease. The Milky Way resisted easy explanation. It was too large to be atmospheric, too diffuse to be fiery streaks, too consistent to be mere accident. The guesses showed both human ingenuity and human limits. Without tools to see more closely, speculation stopped at the edge of imagination. The Milky Way remained a mystery, described, debated, but never resolved. Still, those debates mattered because they transformed wonder into inquiry. They asked not only what the Milky Way meant, but what it was. Even outside Greece and Rome, echoes of similar ideas emerged. In India, philosophers speculated about multiple worlds and countless stars. In China, scholars recorded the Silver River in astronomical charts, carefully noting its width, brightness, and seasonal visibility. Though their frameworks differed, the impulse was the same, to move from story to description, from symbol to observation. Across cultures, the Milky Way was becoming not only myth, but data. This blending of myth and philosophy shaped the centuries to come. When Islamic scholars inherited Greek texts, they questioned and refined Aristotle's ideas. When medieval Europeans studied the night sky, they did so through lenses ground by philosophy as much as by faith. The dome of Aristotle endured, but cracks were forming. The Milky Way, always stubborn, waited for sharper eyes and clearer instruments. To stand under that ancient sky was to live in two worlds at once. By firelight, you might hear the tale of Hera's spilled milk, or of a river where souls walk. In daylight, you might study Aristotle's teachings, imagining celestial fire or atmospheric glow. Both were attempts to grasp the same truth, seen by the same eyes, but framed in different languages, one of God's, one of nature. Both testified to the same human impulse, to locate ourselves in the glow above, to understand why that river of light arched eternally across the night. The dome of Aristotle has long since shattered. We know now the spheres do not exist, that the heavens are not fixed, that the Milky Way is not fire but countless suns. Yet in that ancient dome lay the first structured attempt to place Earth within the galaxy. It may have been wrong, but it was a beginning. It was the moment humanity dared to think the river of milk could be explained not only by myth, but by reason. And that daring, more than the correctness of the answer, carried us forward into the long journey of discovery. In the centuries after Aristotle, his vision of crystalline spheres and celestial perfection dominated thought from the Mediterranean outward. But knowledge does not sit still. It drifts, carried by trade, by conquest, by scholars who translate and preserve what others might burn. When the libraries of Greece waned, the torch of inquiry passed eastward into Persia, into Baghdad, into the heart of Islam's golden age. Here, under skies just as dark, thinkers returned to the Milky Way, not with myths of milk or atmospheric fire, but with sharper questions. Was this glowing band really vapors in our atmosphere, as Aristotle claimed, or was it something far more distant? The dome of philosophy began to crack under the pressure of observation and mathematics. Among the most remarkable voices was Ibn al-Haytham, known in the Latin West as Al-Hazan. Living in the 10th and 11th centuries, he was a man obsessed with light. He studied reflection, refraction, and the workings of the human eye. He built experiments that bent beams through glass and water, showing how vision worked not as Aristotle described, but as physical light entering the eye. His Book of Optics reshaped science for centuries, and within it the Milky Way received a new kind of attention. Al-Hazan argued that the band of light could not be atmospheric fire. It had no parallax, no shift as the Earth rotated. Instead, he reasoned, it must lie far beyond the moon, in the realm of the stars themselves. In other words, it was celestial, not earthly. Other scholars followed this line of thought. Al-Biruni, a Persian polymath, described the Milky Way as a collection of countless small, tightly clustered stars. Qutb al-Din al-Shirazi and his student al-Farisi suggested that the Milky Way's light was the combined glow of many faint stars, too small to resolve with the naked eye. They did not yet have telescopes, but they had keen logic. If the band was diffuse, perhaps it was not because it was one thing, but because it was many. That intuition, so bold, so simple, was one of the great leaps toward truth. These were not idle speculations. They were built upon centuries of careful astronomy. Islamic scholars inherited Greek works, translated them into Arabic, and then improved upon them. They built observatories, mapped star positions with exquisite precision, invented instruments like the astrolabe, and recorded what they saw with mathematical rigor. The Milky Way was charted, its width and position measured, its brightness compared season by season. The data told a different story than Aristotle's vapors. The band did not flicker like fire. It did not shift like a cloud. It was stable, fixed, patterned. It behaved like the stars, because it was stars. The Golden Age was also an age of synthesis. Mathematics, poetry, philosophy, and religion interwove, making the Milky Way not only a subject of science but of culture. In poetry, it remained a river, a bridge, a trail of souls. In astronomy, it became a puzzle of structure and distance. In mathematics, it became a problem of parallax and perspective. This blend of imagination and precision allowed scholars to approach the truth while still holding reverence for the mystery. They did not strip the heavens of wonder. They expanded it, making the Milky Way both a poetic path and a scientific question. Consider what it meant to live under those skies. In Baghdad, in Samarkand, in Cordoba, the nights were deep and brilliant. The river of milk still stretched across them, as familiar as breath. But unlike the Greeks, these scholars had a new context: paper, algebra, geometry, optics. With these tools they could test, calculate, and argue. They challenged Aristotle openly, sometimes with respect, sometimes with boldness. This willingness to question authority was itself terrifying to the old order, but it was the seed of modern science. The Milky Way became a battlefield of ideas, where philosophy and experiment wrestled for dominance. What makes this era so extraordinary is how close they came without telescopes. To say that the Milky Way was made of countless faint stars is essentially correct. They lacked the glass lenses to prove it, but their reasoning was sound. They glimpsed the truth through mathematics and logic, anticipating what Galileo would later show with his telescope. This is one of the hidden triumphs of science. Truths often emerge in whispers centuries before they can be shouted. The Golden Age also showed how global science had become. Knowledge did not flow in a straight line from Greece to Rome to Europe. It curved, arced, crossed deserts and seas. The Milky Way's mystery was carried in manuscripts, translated from Greek to Arabic, later into Latin. Ideas were preserved, debated, and reimagined. By the time Europe reawakened during the Renaissance, it would inherit not only Aristotle's dome, but also Alhazen's optics and Al-Biruni's insight. The Milky Way's story was no longer one of myth alone, nor of philosophy alone. It had become part of a continuous human inquiry, stretching across cultures, languages, and centuries. And so the river of milk deepened. It was no longer just divine milk, celestial rivers, or atmospheric vapors. It was perhaps a swarm of stars, a collective light shining from distances unimaginable. This was a terrifying thought, for it displaced Earth once more. If the Milky Way was made of countless stars, then the heavens were not simple spheres, but vast fields of suns. The universe was larger than Aristotle had allowed, larger than myth had dared, larger than any dome could contain. This chapter of Shadows, Islam's Golden Age, was a turning point. The myths remained, the poetry endured, but the science sharpened. The Milky Way became both beautiful and suspect, its light not an illusion but a clue. To stand beneath it in those centuries was to stand between two worlds, one of mythic rivers and God's milk, the other of faint stars hidden in the haze, waiting for a lens of glass to confirm what reason had already begun to see. In the early 1600s, Europe stood on the threshold of transformation. Wars, plagues, and faith still weighed heavily on daily life, but curiosity was stirring in quiet workshops and libraries. Metalworkers crafted lenses for spectacles. Merchants carried glass across borders, and philosophers debated the heavens with words that strained against the boundaries of tradition. The Milky Way still arched overhead every night, dazzling and mysterious. Some whispered, as Democritus and Al-Biruni once had, that it was made of countless tiny stars. Others clung to Aristotle's belief that it was a kind of atmospheric glow. But in 1609, a small, fragile tube of glass was lifted to the sky, and in that moment, the river of milk ceased to be myth or guesswork. Through Galileo's telescope, the Milky Way became countless stars, and humanity's place in the universe shifted forever. Galileo Galilei was not the first to build a telescope. The invention had begun in the Netherlands, where spectacle makers discovered that two lenses arranged in a tube could magnify distant objects. But Galileo, hearing of the device, improved it, grinding his own lenses with obsessive care until he created an instrument stronger than any before. He pointed it first at earthly targets, the bell towers of Florence, the ships at sea, and then, inevitably, at the heavens. What he saw burned itself into history. The moon was not smooth but scarred, with mountains and valleys. Jupiter had moons of its own, circling it like tiny planets. And when Galileo turned his telescope to the Milky Way, what had seemed a cloudy river dissolved into a storm of stars. The sight was staggering. Galileo described the Milky Way as nothing but a congeries of innumerable stars grouped together in clusters. Where the naked eye saw a haze, the telescope revealed structure, points of light too numerous to count, stars packed so densely that they blurred into brightness. The great band was not smoke, not vapors, not divine milk. It was reality, the light of suns filling space in numbers beyond human imagination. For the first time in history, the true nature of the Milky Way was confirmed, not in poetry, not in speculation, but in sight. This discovery was more than scientific. It was cultural shock. For centuries, people had lived under the dome of Aristotle and Ptolemy, a universe ordered with Earth at its center, encircled by perfect spheres. Galileo's telescope shredded that dome. It showed imperfection in the moon, multiplicity in the planets, and vastness in the Milky Way. The heavens were not a crystalline perfection, but a wilderness, rich and unruly. Earth, once imagined as the heart of the cosmos, was becoming just one among countless worlds in a galaxy of stars. The reaction was not simple acceptance. Many resisted. The Church, deeply invested in the ordered cosmos of Aristotle and Ptolemy, viewed Galileo's revelations with suspicion. His support of Copernicus's heliocentric system, that the Earth moved around the Sun, added to the controversy. To admit the Milky Way was made of stars was to admit the universe was larger, messier, and less human-centered than tradition allowed. Galileo faced condemnation, trial, and silence forced upon him. Yet the telescope could not be uninvented. Once people saw the Milky Way as stars, they could never go back to seeing it as vapors or milk. What made Galileo's vision so powerful was not only what he saw, but how he shared it. He published drawings, notes, and arguments, insisting that the evidence of the telescope was undeniable. The Milky Way's starry nature became part of a broader revolution, the scientific method built on observation, measurement, and proof. This was a turning point. For thousands of years, myths had explained the band of light, and philosophers had speculated about its nature. But Galileo showed that with glass and patience, the truth could be seen directly. It was not only a triumph of astronomy, it was the beginning of modern science. Imagine standing with him in 1609, looking through that tube of glass. The sky you thought you knew suddenly dissolves into millions of lights, each one a star, like the sun. The river of milk is no longer mystical fire, but a window into infinity. It is both exhilarating and terrifying. Exhilarating because the universe is more abundant than you ever dreamed. Terrifying because the Earth feels smaller than ever, a tiny place in a galaxy whose scale defies comprehension. That awe, that mingling of wonder and fear, is still with us today every time we look at the Milky Way in a dark sky. Galileo's telescope did not solve every question. It did not show the structure of the galaxy or our place within it. But it shattered the illusion that Earth was central, that the heavens were simple, that the Milky Way was an atmospheric trick. It revealed the galaxy as a sea of stars, a community of suns. It laid the groundwork for centuries of deeper exploration, from Herschel's star maps to Shapley's globular clusters to the modern Gaia spacecraft. The telescope was the key that opened the door. The journey to find Earth's location in the Milky Way began with that first glimpse through glass. The legacy of Galileo's night remains immense. His simple act, pointing a telescope upward, was both rebellion and revelation. He overturned centuries of belief, endured persecution, and ignited a revolution in how humans see themselves. The Milky Way, once a mythic river, became evidence of cosmic immensity. It no longer reassured people of divine order, it confronted them with human smallness. Yet in that smallness lay a new kind of meaning. The realization that Earth was part of a greater whole, a galaxy whose beauty and terror were larger than myth. Even today, the language Galileo gave us lingers. We still call it the Milky Way, but when we say the words, we no longer mean spilled milk or a celestial river. We mean billions of stars, scattered across a spiral galaxy, with our own sun quietly orbiting among them. That knowledge began in 1609, with a man pressing his eye to glass, daring to look, daring to describe what he saw. The river of milk became a starry ocean, and humanity for the first time understood that it was adrift upon its waves. By the late 18th century, telescopes had grown larger, more refined, their mirrors polished and aligned with obsessive care. The age of mythology and speculation was long past. The age of measurement had begun. Among those who embraced it most fiercely were William Herschel and his sister Caroline, two figures who turned their nights into maps of the heavens. While Galileo had revealed that the Milky Way was built of stars, the Herschels dared to go further. They wanted not just to describe the galaxy, but to chart its shape, to find Earth's location within it, to see whether the river of milk could be sketched like a coastline or a continent. It was an audacious task, measuring the immeasurable, and though their results were incomplete, they carried humanity another step closer to finding its true place in the galaxy. William Herschel was not born an astronomer. He was a musician first, a man who understood rhythm and harmony. But in England, his passion turned to the stars. He ground his own telescope mirrors, experimenting with shapes and sizes until he produced some of the most powerful instruments of his day. His sister Caroline joined him, not only as an assistant, but as a fellow observer, scanning the heavens, recording, calculating. Together, night after night, they set about the painstaking work of mapping. Their ambition was simple in statement, but immense in scale. Count stars in every direction, and from the density of those stars, infer the structure of the Milky Way. They developed a method they called star gauging. Point the telescope at a patch of sky. Count every visible star. Move the telescope slightly. Count again. Repeat, again and again, across hundreds of patches. Where the counts were high, the galaxy must be thicker. Where they were low, it must be thinner. Piece these counts together, and a picture would emerge of the Milky Way's shape and of Earth's position inside it. The work was grueling. Hours in the cold, eyes straining at eyepieces, Caroline writing as William dictated numbers. But slowly patterns emerged. The Milky Way was not infinite. It had form. It was a disk, flattened, elongated, like a great grindstone of stars. And Earth, they concluded, lay near its center, for the star counts seemed roughly balanced in opposite directions. Their famous diagram, published in 1785, showed a rough cross-section of the galaxy, a flattened system of stars with the sun near the middle. For the first time in history, humanity had something like a map of the Milky Way. The Herschel's conclusion was wrong in detail, but right in spirit. Earth is not near the center. It is displaced, orbiting quietly about 26,000 light-years from the core. But given the tools they had, their reasoning was remarkable. They assumed all stars were of similar brightness, which made their distances impossible to distinguish. Dust clouds, the dark lanes of the Milky Way, obscured their view, making the star counts deceptive. Yet their vision was daring, to treat the galaxy as a structure, not just a spectacle, and to locate Earth within it as one point among many. Their work also revealed something new. The galaxy was not uniform. They discovered star clusters, double stars, nebulae, objects that suggested the Milky Way was more complex than a simple grindstone of light. Caroline herself discovered 8 comets and over a dozen new nebulae, her observations expanding the catalogue of the heavens. Together, the Herschels moved astronomy beyond wonder into architecture. They were not only describing stars, they were building a floor plan of the cosmos. The cultural impact was immense. For millennia, humans had told stories of the Milky Way as divine milk, rivers or pathways. Now, here was a diagram, a sketch that placed Earth inside a starry disk. It was humbling and electrifying. The myths gave meaning, but the Herschels gave perspective. The river of milk was no longer an abstraction. It was a system with shape and depth, and humanity was part of it. Yet their diagram carried with it a haunting truth. Even in their attempt to chart the whole, their view was limited. The telescope showed stars, but it could not pierce the dust that veiled the galaxy's center. Their map placed Earth in the middle, not because it was, but because their vision could not yet see beyond the clouds. It was a reminder that discovery is always partial, that knowledge grows layer by layer. Still, their misstep was not failure, but progress. By daring to draw the Milky Way, they laid the foundation for future astronomers to correct and refine. The Herschels' legacy is not only in their diagram, but in their method. They treated the galaxy as something measurable. They transformed the Milky Way from a mystery to a problem, one that could be solved with patience, observation, and numbers. They brought science closer to answering the question humanity had whispered since the first myths. Where are we in all this light? Even today, their sketch feels symbolic. It was crude, yes, distorted, yes, but it was the first human attempt to see the galaxy from the inside. It was like drawing the shape of the forest while standing among the trees, counting trunks and trying to imagine the whole. Their courage was not in accuracy, but in imagination. They believed the Milky Way had structure and that humanity could know it. That belief carried astronomy into a new era. To stand under the night sky with William and Caroline Herschel was to see not only stars but data, not only beauty but measurement. Their star counts turned wonder into numbers, their diagrams turned myth into geometry. They did not yet know about spiral arms or galactic centers, but they knew Earth was inside something vast and flattened, a starry disk that encircled all horizons. They glimpsed the shape of home, even if through a haze. This was the beginning of galactic cartography, the first rough map of the Milky Way. The river of milk had been transformed, through their eyes and hands, into a system with form. Humanity's search for its location had taken a giant step, from poetry to diagram, from story to structure. The Herschels did not have the final answer, but they gave the question new life. Where are we? Not at the center of creation, perhaps, but within a galaxy that could be measured, mapped, and known. Through the polished mirrors of telescopes and the sharpened eyes of astronomers, the Milky Way began to look less like a continuous river and more like a broken one. The Herschels had drawn it as a great disk of stars, but observers soon noticed something unsettling. There were places where the glow was torn apart, split by dark streaks and empty spaces. At first glance, it seemed as though stars simply ended in abrupt patches, as if the galaxy itself had holes. But the truth, slowly dawning in the 19th century, was even stranger. These were not gaps in the universe. They were shadows, clouds of invisible matter blotting out the light. The Milky Way, far from being transparent, was veiled in hidden truths. Early observers puzzled over these dark lanes. Through small telescopes, the brilliant starfields of Sagittarius and Cygnus were sliced apart by vast, dark rifts. They were so striking that they became part of star lore. The Great Rift stretching through the Summer Triangle, the Coal Sack near the Southern Cross, the Black River dividing the Milky Way into twin streams. To the naked eye, they were obvious, yet their nature was a mystery. Were they holes in the sky, windows into nothingness? Or were they filled with matter that human eyes could not see? John Herschel, son of William and Caroline's legacy, took up the question during his surveys in the Southern Hemisphere. Observing from South Africa in the 1830s, he marveled at the coal sack, calling it a vacancy in the heavens. He resisted the idea that stars simply stopped. Instead, he suspected something intervened, clouds or vapors so thick they concealed what lay behind. His careful records helped shift thinking. The Milky Way was not smooth but textured, its light not merely absent but blocked. As astronomy advanced, the suspicion grew stronger. Spectroscopy revealed that stars' light could be dimmed and reddened as it passed through intervening material. Interstellar dust, microscopic grains of carbon, silicates and ices floated between stars, scattering and absorbing light. These clouds were vast, stretching for hundreds of light years, dark enough to carve shapes into the galaxy itself. What once seemed like nothingness was, in fact, presence. The Milky Way was not a clear window but a canvas with shadows painted across it. This realization reshaped the search for Earth's location. William Herschel's star counts had been misled by dust. He believed Earth was central because thick clouds blocked his view toward the true galactic core. The apparent symmetry in his data was not cosmic design, but cosmic obstruction. Only by understanding these dark lanes could astronomers begin to correct their maps, to see beyond the veil. The Milky Way was not a flat grindstone of evenly scattered stars. It was a disk threaded with clouds, knots and gaps, alive with hidden structures. For ordinary stargazers, the discovery deepened awe. To look at the coal sack or the great rift with the naked eye is to feel the presence of absence. The darkness is not empty. It is full, so full that even the light of countless stars cannot pierce it. These regions became both terrifying and beautiful, symbols of mystery within mystery. They hinted that the universe was layered, that what we see is only a surface. Beyond the black clouds lay more stars, more light, more secrets. As instruments improved, astronomers realized these clouds were not only obstacles, but cradles. Within them, stars were born. Telescopes in infrared light, invisible to the eye, revealed glowing cocoons where gravity pulled dust and gas together, igniting nuclear fire. The very shadows that once seemed dead were in fact nurseries, places of creation. The Milky Way's dark lanes were not scars of absence, but wombs of abundance, hiding both destruction and renewal. The 19th century closed with a new vision. The galaxy was dynamic, not static. Its light could be hidden, its truth obscured, its shape distorted by matter we could not see. Earth's place could no longer be charted by star counts alone. A more powerful method was needed, something that could pierce the dust, measure distances, and reveal the true scale of the Milky Way. That method would come in the 20th century, with the mapping of globular clusters and the realization that Earth was not central after all. But the first hint of that truth came from the shadows. These dark lanes remind us that discovery often begins in confusion. What looks like absence may be presence. What seems like an ending may be a veil. The Milky Way is not a smooth river, but a braided one, its currents divided by sandbars of dust, its light interrupted by cosmic shadows. To the ancient eye, it was milk or fire. To the Herschels, it was a disk. To the 19th century, it became a galaxy laced with darkness, hiding truths we had only begun to glimpse. To stand beneath the night sky, to trace the dark rift cutting across the Milky Way, is to share the awe of those astronomers. The stars blaze, but the shadows are just as profound. They whisper that the universe is deeper than sight, that Earth's place is not only in the light, but in the layers between. They remind us that to find our location in the galaxy, we must look not only at what shines, but at what hides. At the dawn of the 20th century, astronomy stood at a crossroads. Telescopes had grown enormous, mirrors polished with precision, and photographic plates captured light invisible to the eye. The Milky Way was no longer just a river of stars. It was a problem begging for measurement. Where exactly was Earth inside it? Was the sun central, as the Herschels believed, or was there something more unsettling at play? Into this question stepped Harlow Shapley, an American astronomer with a determination to measure the immeasurable. His tools were not myths, not even ordinary stars, but the great spherical swarms known as globular clusters, ancient beacons scattered around the edges of the galaxy. By charting their positions, he shifted Earth once again, moving it from the center of the Milky Way to the quiet suburbs, far from the galactic core. Globular clusters are among the oldest structures in the universe, tight balls of hundreds of thousands of stars bound by gravity, hanging like lanterns around the galaxy. To the naked eye, some appeared as fuzzy patches of light, Omega Centauri, M13 in Hercules. Through telescopes, they revealed themselves as glittering spheres, stars packed so densely they looked like cosmic beehives. Shapley realized these clusters could serve as markers. If he could measure their distances and plot their distribution, he might see the shape of the Milky Way, not from a single point of stargazing, but from a three-dimensional map. The key lay in Cepheid variable stars, pulsating suns whose brightness rose and fell in predictable cycles. Henrietta Leavitt, working at Harvard's observatory, had discovered that the period of a Cepheids pulsation was linked to its true brightness. Measure how quickly it pulsed, compare it to how bright it appeared, and you could calculate its distance. It was a cosmic yardstick, the first reliable method of measuring stars far beyond the reach of parallax. Shapley seized on this breakthrough. He searched the globular clusters for Cepheids, clocked their rhythms, and derived their distances. The results were staggering. The clusters were not scattered randomly. They formed a halo, a spherical swarm surrounding a center, and that center was not near Earth. It was tens of thousands of light-years away, in the direction of Sagittarius. The Sun, it turned out, was not the heart of the galaxy, but far off to the side, orbiting quietly in one of its spiral arms. The Herschels, blinded by interstellar dust, had placed us at the center. Shapley, with Cepheids and clusters, pushed us outward, decentralizing humanity once again. The cultural shock echoed the one Galileo had caused centuries earlier. First, Earth had lost its place at the center of the universe. Then it lost its place at the center of the solar system. Now, Shapley showed, it was not even central in its own galaxy. The Milky Way was far larger than anyone had guessed, on the order of 100,000 light-years across, and Earth was a provincial speck within it. Humanity's sense of importance shrank, but our sense of scale expanded. The galaxy itself became a stage, and we were no longer at its spotlighted center, but at its dimmer edge. Shapley's announcement in the 1910s met resistance. Some astronomers clung to older ideas, insisting the galaxy was smaller and the Sun nearer the middle. Others doubted his distances. But the logic of the clusters held. Photographic plates confirmed the Cepheids, the globulars gathered undeniably toward Sagittarius, and the halo revealed the true galactic architecture. Shapley had redrawn the map, and Earth's location was now fixed not at the throne of creation, but on a side seat in a vast spiral disk. The psychological effect was profound. Myths had once placed us in the center of divine order. Aristotle's spheres had encased us at the focus of perfection. Even Herschel's maps had implied balance. Shapley stripped away the illusion. We were peripheral, orbiting far from the heart, one star among billions, one world among countless suns. And yet this displacement was strangely liberating. To be off-center was to be ordinary, and to be ordinary was to belong to the galaxy as a whole, not as its ruler, but as one of its children. Globular clusters remain markers of humility. To see one through a telescope is to glimpse an ancient swarm, older than Earth, holding secrets of the galaxy's formation. To Shapley, they were guideposts, lighthouses marking the true core of the Milky Way. To us, they are reminders that Earth has always been smaller than our imagination first allowed. They taught us that finding our location means accepting our scale. Shapley's work set the stage for one of the greatest debates in astronomy, the question of whether the Milky Way was the entire universe or just one of many galaxies. But before that argument unfolded, his mapping of clusters had already changed the conversation. The Milky Way was vast, structured, and Earth was not central. The river of milk had grown into a galactic ocean, and we were on its shore, not at its heart. To stand beneath the stars after Shapley's discovery was to feel the ground shift under your feet. The familiar band of the Milky Way still arched overhead, but it no longer placed you in the middle of all things. Instead, it carried you outward, into the margins, into humility. It was the next step in humanity's long journey of decentering, each revelation both diminishing and expanding us. We were smaller than we dreamed, yet part of something greater than we had ever dared imagine. In the spring of 1920, inside the walls of the Smithsonian in Washington, D.C., astronomy reached one of its great turning points. On that day, Harlow Shapley, who had moved the Sun to the outskirts of the Milky Way, faced Heber Curtis, an astronomer from California who believed the universe was far larger than Shapley allowed. Their confrontation became known simply as the Great Debate, and though it unfolded in careful speeches rather than shouted arguments, the stakes were nothing less than the scale of the cosmos itself. Was the Milky Way the entire universe, immense and all-encompassing, with the Sun orbiting far from its center? Or was it merely one galaxy among countless others, with spiral nebulae like Andromeda standing as island universes beyond our own? Shapley came armed with his globular clusters. He had charted their distribution and shown convincingly that the Milky Way was vast, perhaps 300,000 light-years across, and that the Sun was nowhere near the center. To him, this immensity left no room for rival galaxies. The spiral nebulae, those faint cloud-like swirls that telescopes revealed, were not separate universes, he argued, but structures within the Milky Way itself, possibly solar systems in formation or peculiar star clusters bound by its disk. His vision kept the Milky Way supreme, not infinite, but large enough to contain all that could be seen. Curtis, by contrast, leaned on evidence from those very spiral nebulae. He pointed to photographs showing dark lanes resembling the dust clouds within our own Milky Way, to novae that had erupted within Andromeda, whose faintness suggested immense distance. If those novae were as bright as similar ones in our galaxy, then Andromeda must lie far beyond the Milky Way, millions of light-years away. Curtis embraced the radical idea that the universe was filled with galaxies, each as large as the Milky Way, each an island of stars adrift in a cosmic ocean. The debate highlighted the limitations of the time. No telescope was yet powerful enough to resolve individual stars in distant galaxies. Distances were uncertain. Cepheid variables had not yet been fully exploited in the spiral nebulae, and the concept of an expanding universe was still years away. Both men argued with passion, citing evidence that was suggestive but incomplete. Shapley defended a single, all-encompassing Milky Way. Curtis envisioned a universe of galaxies stretching into infinity. The truth, as later discoveries would prove, leaned toward Curtis. In the 1920s, Edwin Hubble, using the 100-inch Hooker telescope at Mount Wilson, identified Cepheid variable stars in Andromeda. Their rhythms revealed distances far beyond the boundaries of the Milky Way. Andromeda was not a cluster within our galaxy, but a galaxy in its own right, 2 million light-years away, larger even than the Milky Way itself. Curtis's island universes became the new paradigm, and the scale of the cosmos expanded beyond anything Shapley had imagined. Yet Shapley was not wholly wrong. His mapping of globular clusters had correctly placed the Sun far from the galactic center and had given a sense of the Milky Way's immense size. His error lay in underestimating how small the Milky Way was in the larger scheme. He had dethroned the Sun from the center of the galaxy, but Curtis dethroned the galaxy from the center of the universe. Together, their arguments marked the beginning of modern cosmology. The great debate was less about victory than about opening doors. For centuries, humans had been shrinking in cosmic scale. Earth was no longer central, the Sun was no longer central, and now even the Milky Way was not central. Each step away from the center carried both loss and wonder. We were not the hub of creation, but part of something endlessly larger. The river of milk, once the universe entire, became one spiral among billions, each containing its own rivers of light. For those who looked up at the night sky, the change was dizzying. That hazy band was still beautiful, still familiar, but it was no longer the boundary of existence. Beyond it lay other galaxies, other star systems, other worlds. The Milky Way was home, but not the only home. The scale of belonging had expanded beyond comprehension, and humanity had to learn to live in a universe where even our galaxy was not unique. The great debate reminds us how science advances, not with instant clarity, but with arguments, evidence, and corrections over time. Shapley gave us a Milky Way vast enough to dislodge Earth from its center. Curtis gave us a universe vast enough to dislodge the Milky Way from its throne. Both gave us humility. Both gave us wonder. and both left behind a legacy of daring to ask, how big is the universe, and where do we stand within it? The decade after the Great Debate was short in years, but immense in consequence. In 1923, at the Mount Wilson Observatory in California, Edwin Hubble lifted his eye to the eyepiece of the 100-inch Hooker telescope, the largest in the world at the time. His target was the Andromeda Nebula, a faint, cloud-like swirl that had puzzled astronomers for centuries. Some thought it was a cloud of gas within our own Milky Way. Others, like Curtis, suspected it was an entire galaxy far beyond. Hubble's telescope, more powerful than any before it, allowed him to resolve what no one else could. Not just haze, not just a blur, but individual stars flickering within Andromeda. Among them, he identified a special type, a Cepheid variable star, whose rhythmic pulsing carried the key to distance. With this observation, Hubble proved what had only been speculation. Andromeda was not within the Milky Way. It was another galaxy, millions of light years away. The universe was larger than anyone had dared to imagine. That single discovery was a breaking point. For centuries, the Milky Way had been assumed to be the universe entire, a grand disk of stars, perhaps with the sun at its center, perhaps with the sun off to the side. But still, it was thought to be everything. Now, with the Cepheids' pulse as a cosmic yardstick, Hubble showed that Andromeda lay far outside the bounds of our galaxy. If Andromeda was its own island of stars, so were the countless other spirals seen through telescopes. The Milky Way was not the universe. It was one galaxy among billions. The cultural shock was profound. Imagine living in a world where the Milky Way had been described as all-encompassing, the backdrop to every star you could see, the totality of the heavens. Then suddenly you are told that this river of milk is just one stream in a vast ocean of rivers, each stretching beyond sight. Earth's place shrank once again. Not only were we not the center of the galaxy, but our galaxy itself was not the center of the universe. The scale of displacement was dizzying. Humanity had fallen from throne after throne, Earth no longer the center of creation, the sun no longer the center of the solar system, the Milky Way no longer the universe. Each revelation made us smaller, and yet the universe larger, more magnificent, more humbling. Hubble's discovery did more than expand scale. It opened entirely new questions. If there were galaxies beyond our own, how many were there? How were they arranged? Did they move? Were they eternal or changing? Soon, with further observations, Hubble revealed that galaxies were not static. Their light was redshifted, stretched by motion away from us. The farther a galaxy lay, the faster it seemed to recede. This was not only proof of galaxies, but proof of an expanding universe. The Milky Way was adrift, along with Andromeda and all the others, in a cosmos that itself was stretching outward. The river of milk was now just one current in a cosmic tide. The shift in imagination was staggering. Astronomers had once debated whether the Milky Way was the universe. Now, less than a decade later, they were grappling with a universe filled with galaxies, each containing billions of stars, each separated by unimaginable gulfs of space. Andromeda, once thought a faint mist, was revealed as a neighbor galaxy larger than our own, with its own clusters, its own dust lanes, its own spiral arms. To know this was to know that the Milky Way was not unique, not supreme. It was ordinary, one among many, and Earth's place within it was no longer a throne, but a vantage point, small and temporary, in a cosmos too vast to fully imagine. Hubble's work did not erase the Milky Way's importance. If anything, it deepened it. The galaxy remained home, a spiral of stars within which our sun drifted. But now that home was contextualized. It was a single house in a city of galaxies, itself in a country of galaxy clusters, within a universe expanding outward. To understand Earth's location in the Milky Way was now only part of the journey. The greater challenge was understanding the Milky Way's location in the cosmos. For ordinary people, the effect was both terrifying and exhilarating. To look at the night sky and know that those faint spirals were entire galaxies was to feel dwarfed, yet also connected. The universe was not smaller than belief, but far larger than imagination. The myths of Hera's milk, the diagrams of Herschel, the debates of Shapley and Curtis, all were chapters in a story that now turned outward, toward infinity. The discovery also reshaped language. Island universes, once a poetic term, became fact. The Milky Way was one island, Andromeda another, and beyond them an archipelago without end. Earth's position could no longer be understood solely by star counts or dust lanes. It had to be seen in relation to a universe of galaxies, each with their own centers, clusters, and mysteries. The story of location had expanded beyond measure, and yet, in this vastness, the Milky Way retained its power. To stand under the stars, to see the river of milk stretch across the sky, is still to see the universe from within, to feel the immensity pressing down. Now we know that this river is only one among billions, but that knowledge does not diminish its wonder. It enhances it, reminding us that the light above our heads is both home and clue, both local and universal. With Hubble, the question of Earth's place grew deeper, layered. No longer was it enough to ask, where are we in the Milky Way? We had to ask, where is the Milky Way in the universe? The answer was no longer centrality, but drift, no longer supremacy, but membership. We are part of a galaxy, which is part of a cluster, which is part of a web stretching across the cosmos. Earth is a thread in that tapestry, small but luminous. By the middle of the 20th century, telescopes had advanced beyond Galileo's lenses and Herschel's mirrors. Photographic plates captured more than human eyes could register, and spectroscopes split light into its hidden colors. Yet even with these tools, the Milky Way refused to yield its full structure. The problem was dust, vast clouds of interstellar material veiling the galaxy's true form. Optical telescopes could only see so far before the stars faded behind a curtain of darkness. The great star counts of Herschel, the distances measured by Shapley, the revelations of Hubble, all pointed to the Milky Way as vast and complex, but its skeleton remained invisible. If Earth was to know its precise location in this galactic city, astronomers needed new eyes, eyes that could pierce the dust. Those eyes came in the form of radio astronomy, and with them the spiral arms of the Milky Way finally revealed themselves. The breakthrough came from the discovery that neutral hydrogen, the most abundant element in the universe, emits radio waves at a wavelength of 21 centimeters. Unlike visible light, radio waves pass through dust clouds unimpeded, traveling freely across the galaxy. This meant that by tuning antennas to that wavelength, astronomers could map the distribution of hydrogen gas across the Milky Way. And because hydrogen marks the raw material of stars, tracing it would outline the very structure of the galaxy. The arms where stars were being born, the lanes along which gas and dust pooled, the spiral skeleton hidden behind the veil. In the 1950s, teams across the world, most famously in the Netherlands and the United States, turned giant radio dishes to the sky. As they swept the galaxy, they recorded hydrogen's faint whispers. The signals, shifted in frequency by the Doppler effect, revealed not only the presence of gas, but its motion. By combining these measurements, astronomers built the first maps of the Milky Way's spiral arms. For the first time, humanity could sketch the galaxy from within, seeing the pattern of whorls and arcs that had been invisible to optical telescopes. The results were breathtaking. The Milky Way was not a featureless disk, nor just a grindstone of stars. It was a barred spiral galaxy, with arms sweeping outward in graceful curves, each packed with stars, gas and dust. Within those arms, stellar nurseries glowed, clusters formed and supernovae detonated. Between them, vast gaps stretched, dark and less crowded, and Earth, our sun, was not in a grand arm at all, but in a minor spur, a small offshoot between the Sagittarius arm and the Perseus arm. Our neighborhood was christened the Orion Spur, a cosmic side street in the galactic city. The discovery was humbling. For centuries, humans had imagined themselves central, first on Earth, then in the Sun system, then perhaps in the Milky Way itself. Now the truth was clear. We were not central. We were not in a major arm. We were on the edge of a spur, orbiting quietly around the galactic core, far from the galaxy's luminous heart. Our place was not grand but ordinary, not commanding but peripheral. Yet in that ordinariness lay beauty. We were part of the pattern, woven into the spirals of creation, participants in a structure far larger than imagination had once allowed. The cultural echoes of this discovery were profound. To say Earth was in the Orion Spur was to rewrite humanity's address. It was like realizing your home was not in the city center, but in a modest neighborhood on its edge. It diminished the ego, but expanded the wonder. The Milky Way was no longer just a hazy river overhead. It was a spiral galaxy with architecture, with symmetry, with motion, and we were inside it, circling its center like one mote among billions. The Orion Spur itself carries poetry. It is not vast like the Perseus arm, not brilliant like Sagittarius, yet within it lies our sun, our Earth, our history. The dust and gas here gave birth to the solar system, forged its planets, and lit the path for life. To be in a spur is not to be lesser, it is to be unique. It is to have a vantage point both humble and profound. From this cosmic side street, we gaze outward, mapping the spiral that shelters us, knowing that our view is shaped by our position. Radio astronomy not only revealed the spiral arms, but also refined Earth's distance from the galactic center, about 26,000 light-years. This placed us firmly in the disk, orbiting the core at a speed of over 800,000 kilometers per hour, completing one galactic revolution every 225 million years. Earth had a trajectory, a path through the galaxy, a rhythm of motion that linked it to the stars. To know this was to see our home as part of a greater dance, circling not only the sun, but the galactic nucleus itself. The act of mapping the spiral arms was both scientific and spiritual. It transformed the Milky Way from mystery to mechanism. But in doing so, it did not diminish its wonder. It deepened it. The dark rifts once thought to be empty were revealed as nurseries of creation. The haze once thought to be vapors was revealed as star fields uncountable. And Earth, once thought central, was revealed as peripheral, but no less precious. The Orion Spur became our new home address. It told us where we stand in the galaxy, not at the core, not at the edge, but in between, in a place where stars are born, where planets form, where life has emerged. The river of milk, once mythic, once mysterious, was now mapped with precision. And yet, even with maps and measurements, the Milky Way remained overwhelming, too vast to grasp in full. The spiral arms stretched beyond sight. The galaxy's core glowed hidden in dust, and Earth's orbit carried us quietly along. To look up at the Milky Way after radio astronomy is to see more than light. It is to see structure, pattern, placement. It is to know that we belong to a spiral galaxy, and that within that galaxy we orbit on a spur, a side street glowing with ordinary stars. It is to accept our smallness and marvel at the immensity that holds us. And it is to feel the question deepen. If we know where we are in the Milky Way, what does it mean to be here, on this small world, in this quiet arm, in a galaxy among billions? The Orion Spur is not grand, not sweeping, not the headline arm of the galaxy. It is a modest fragment, a minor bridge of stars and dust between two larger rivers of light, the Sagittarius arm on one side and the Perseus arm on the other, And yet this is where the Sun was born. This is where Earth orbits, circling endlessly around the galactic center. This quiet spur, this galactic side street, is our home address in the Milky Way. To know this is to know both humility and wonder, for it means that life, history, and all of human memory have unfolded not in the center of the galaxy, but on its periphery, in a neighborhood that seems ordinary, but is extraordinary in its ability to sustain us. When astronomers first mapped the Orion Spur through radio astronomy, they found it stretched only a few thousand light-years, dwarfed by the massive spiral arms that defined the galaxy's skeleton. It is not continuous but fragmentary, a spur rather than a full arm, a corridor rather than a highway. Yet within it lies some of the most remarkable scenery of our sky. The Orion Nebula, glowing with newborn stars, sits within it. The Horsehead Nebula, etched in dust against hydrogen's red glow, is part of it. The Pleiades cluster, bright and jewel-like, belongs to its spread. To look up at Orion in the winter sky, to see its belt and sword, is to gaze directly into the heart of our spur. Our Sun orbits within this spur about 26,000 light-years from the galactic center, positioned in a zone that astronomers call the galactic habitable zone. Too close to the center, and radiation, supernova and black holes make life precarious. Too far out, and the supply of heavy elements needed to build planets is scarce. Here, in the Orion Spur, the balance is just right. The Sun has access to the metals forged in earlier generations of stars, enough to form rocky planets like Earth. Yet it is distant from the chaos of the galactic core, spared the bombardment of constant explosions and gravitational upheavals. Our location is not only humble, it is fortunate. The Orion Spur is also a vantage point. From here, we can look inward toward the dense star fields of Sagittarius, where the galactic core hides behind curtains of dust. We can look outward toward Perseus, into quieter, more open regions of the galaxy. From this side street, the view is panoramic. We see both the crowded downtown and the quieter suburbs. The river of milk arches across our sky, precisely because we are embedded within its disk. Our position gives us the gift of perspective, to see the galaxy not from above, like a map, but from within, like a traveler on its roads. Life in the spur is also shaped by motion. Our Sun orbits the galactic center once every 225 million years, carrying Earth and its planets with it. During that journey, we weave in and out of spiral arms, sometimes encountering denser regions of gas and stars, sometimes passing through calmer stretches. Our spur buffers us, sheltering us from the most crowded lanes while still giving us access to the raw materials of creation. It is a cosmic rhythm we cannot feel daily, but one that shapes the long history of our planet. Extinctions, bursts of star formation, even the bombardment of comets may be tied to our orbit through these galactic landscapes. The Orion Spur reminds us of scale. A few thousand light-years may seem vast beyond imagination, but compared to the Milky Way's full diameter of over 100,000 light-years, it is small, almost incidental. And yet, within this small space lies our solar system, our constellations, our myths. The Greek hunter Orion gave his name to this spur not because he knew its astrophysical truth, but because he gazed at its stars and wove them into story. Today we know that those stars are not only symbols, but markers of our location. The myth and the science overlap, one in metaphor, the other in measurement, both pointing to the same truth. We live in Orion's realm, a spur of light among giants. This spur is not empty. It is alive with stellar nurseries, with clusters, with the slow drift of suns. The Orion Nebula alone contains thousands of young stars, their radiation carving shapes into clouds of gas. The Horsehead Nebula, like a silhouette cut from smoke, shows the artistry of dust sculpted by light. These regions remind us that the galaxy is not static, but generative. Our spur is a cradle as much as a corridor, and somewhere in this cradle, 4.6 billion years ago, a star ignited that would become our sun, surrounded by a disk of dust and gas that spun into planets. One of those planets would cradle oceans, mountains, and life. One of those lives would look up and wonder where it all began. To know we are in the Orion spur is to accept that we are not central, not commanding, not cosmic royalty. But it is also to know we are positioned in a place that gave us everything we needed. Too close to the galactic center, and we might never have formed. Too far, and we might never have had the ingredients of life. Here, in this quiet arm, the balance holds. It is as though our spur is not the grand highway of the galaxy, but the quiet lane where, against all odds, life could take root. The Orion spur also teaches humility. When we map the Milky Way, we must remind ourselves that our vision is always shaped by our position. We draw spirals, arms and bars as though from above, but we have never seen them directly. We infer them from hydrogen maps, from the motion of stars, from comparisons to other galaxies. Our maps are projections, not photographs. And always, they are drawn from the vantage point of the Orion spur. Our neighborhood defines our perspective, just as surely as our planet defines our lives. To locate Earth is to locate it here, on this side street, circling quietly in the outskirts of the galaxy. And yet, there is pride in this ordinariness. From this spur, humans have mapped stars, walked on the moon, sent probes beyond the solar system. From this lane of the Milky Way, we have looked outward and found other galaxies, billions of light years away. From this modest perch, we have begun to understand black holes, dark matter, and cosmic expansion. The Orion spur is no throne, but it is a balcony, and from it we see the universe. To stand outside on a clear night, to trace Orion's belt and sword, is to look directly into the heart of our neighborhood. The stars of Orion are our markers, our local signposts, glowing reminders of the spur we inhabit. Their light has traveled hundreds of years, sometimes thousands, to reach us. They tell us that we are not alone in this galactic road, but surrounded by companions, by fellow suns, by the endless hum of creation. The Orion spur is not grand, but it is home, and home, in the galaxy, is enough. At the heart of the Milky Way lies a mystery that has both terrified and fascinated humanity. The galactic center, a place we cannot see with our eyes, but whose presence shapes everything. For centuries, astronomers knew the Milky Way arched brightest toward the constellation Sagittarius. There the band of light thickens, star fields crowd together, and the dark rifts of dust obscure whatever lies behind. To the naked eye, it looks like a luminous bulge bisected by blackness. To early observers, it was simply the most brilliant part of the river of milk. But as instruments grew more powerful, first photographic plates, then radio telescopes, then infrared detectors, the truth emerged. Behind the dust and haze sits the galaxy's beating heart, a supermassive black hole millions of times the mass of the Sun, around which everything in the Milky Way revolves. The discovery did not come all at once. In the mid-20th century, astronomers began pointing radio telescopes toward Sagittarius. They found a strong, compact source of radio waves, which they called Sagittarius A. Unlike the diffuse glow of gas clouds, this signal was sharp, bright, and steady. Something powerful resided there, hidden behind the veils of dust that blocked optical telescopes. Over the following decades, as technology advanced, astronomers resolved it more precisely into Sagittarius A star, a region so small yet so energetic that nothing ordinary could explain it. The simplest, most compelling answer: a black hole. Black holes were once theoretical oddities, predicted by Einstein's equations, but doubted by many. yet Sagittarius A star fit perfectly. To test it, astronomers tracked the motion of stars near the galactic center using infrared telescopes that could peer through the dust. What they saw was astonishing. Stars whipped around the invisible point in tight, fast orbits, some moving at thousands of kilometers per second. One star, later named S2, completed an orbit in just 16 years, on a path that carried it perilously close to the unseen monster. The only possible object that could exert such gravitational pull in such a tiny region was a black hole. Not just any black hole, but a supermassive one containing about 4 million solar masses. This revelation transformed our understanding of the galaxy. The Milky Way was no longer a diffuse disk drifting aimlessly. It was a rotating system anchored by gravity at its center, its stars, gas and dust all orbiting the black hole's unseen weight. The spiral arms, the bulge, even our sun, all of it circled Sagittarius a star, bound to its gravity like moths around a flame we cannot see. Earth, drifting in the Orion spur, was revealed to be part of this grand orbit, moving in a cosmic dance choreographed by the galaxy's heart. The idea of a black hole at the center is both terrifying and awe-inspiring. To human imagination, black holes are cosmic predators, devouring everything. But in reality, the one at our core is mostly quiet. Sagittarius. A star is not actively feeding on large amounts of matter. It flickers gently, releasing bursts of energy now and then, but it is not a raging quasar. Its role is less dramatic but more profound. It is the anchor, the weight that holds the Milky Way together. Without it, the orbits of stars would be different, the structure unstable. It is the silent ruler of the galaxy, invisible but inescapable. Seeing the galactic center through modern instruments has been like peeling back layers of shadow. Infrared images reveal a maelstrom of stars packed densely, moving in chaotic orbits around the black hole. Radio maps show jets and flares as material brushes too close to the event horizon. X-ray telescopes capture the bursts of energy that erupt when gas spirals inward, heating to millions of degrees before disappearing forever. Even gravitational wave detectors hint that the center is a place of collisions, where black holes and stars dance dangerous steps near the edge of eternity. The galactic center is also a place of paradox. It is hidden, veiled by dust, unreachable by optical eyes. Yet its gravity reaches across the entire galaxy, shaping every orbit, defining the Milky Way's architecture. It is both absent and present, invisible yet fundamental. To know our place in the galaxy is to know that we are bound to this shadow, circling it as surely as Earth circles the sun. The river of milk, once a myth of gods and souls, is in truth a spiral of stars all caught in the embrace of a singular darkness at its heart. For humanity, this knowledge is humbling. We are not near the center. We are not even in a major arm. Yet the black hole's presence touches us, pulling Earth on its 225 million-year orbit around the galaxy. Every creature that has ever lived, every civilization that has ever risen, has been carried along on this silent journey. The dinosaurs walked the Earth when the sun was in a different part of the Milky Way. The first humans looked up at the sky while our solar system was already halfway around the galactic circle. The black hole has been our anchor for billions of years, unseen yet inescapable. In recent years, we have even seen it directly, or rather seen its shadow. In 2022, the Event Horizon Telescope collaboration released the first image of Sagittarius A star, a glowing ring of radio light surrounding a dark center. The image was blurry, imperfect, but monumental. For the first time, humanity looked upon the heart of its own galaxy, a cosmic fingerprint of the black hole that rules us all. It was a reminder that even the most invisible truths can be captured with patience, ingenuity, and collaboration across continents. The galactic center is no longer just the brightest patch of the Milky Way or a philosophical guess. It is a physical reality, a supermassive black hole shaping our galaxy, defining its motion and giving it form. To know this is to know our place. Earth is not central, not unique, not supreme, but it is part of a galaxy with a heart, a galaxy alive with orbits and arms, a galaxy held together by a singular, invisible anchor. The night sky looks peaceful. Stars shine steadily. The Milky Way arches quietly across the darkness, and from the surface of Earth nothing seems to move. But this calm is an illusion. Every star is in motion, every cluster is drifting, and our own sun is racing through space at a speed so great that human language can barely capture it. We are circling the core of the Milky Way, bound to an invisible heart we cannot see, carried along in an orbit that takes hundreds of millions of years to complete. The measurement of this orbit, the effort to locate precisely how far we are from the galactic center, is one of the great achievements of modern astronomy. It is not simply a matter of numbers. It is a matter of identity. To know Earth's distance from the galactic core is to know our cosmic address with greater precision than myth, philosophy, or early telescopes ever allowed. The key to this measurement lies in stellar orbits, the paths of stars near the galactic center. For centuries, astronomers could only guess where the true center was. The Milky Way was brightest towards Sagittarius, but the thick dust clouds made it impossible to see what lay beyond. It was like trying to map the heart of a forest from within, with the densest trees obscuring the center. Radio astronomy changed that, revealing a compact, powerful source known as Sagittarius A star. Later, infrared observations cut through the dust to track the stars themselves. These stars move in tight, rapid orbits around something invisible. Watching them became like watching planets orbit the sun. By measuring their speed and trajectory, astronomers could pinpoint not only the existence of a supermassive black hole, but also its distance from us. One of the most famous of these stars is called S2. It is massive, luminous, and its orbit around Sagittarius A star takes just 16 years. From Earth, it appears as a faint dot in high-powered infrared telescopes, but that dot has traced a path that reveals extraordinary truths. As S2 swings close to the black hole, its speed reaches thousands of kilometers per second, faster than any object in our solar system. Its orbit, carefully tracked, has given us a ruler by which to measure our position in the galaxy. By comparing its apparent size and movement on the sky with the known laws of gravitation, astronomers determined that we are about 26,000 light-years from the galactic center. That number, unimaginable in human terms, has become one of the most important coordinates in our understanding of the cosmos. Think of what that distance means. A single light-year is about 9.5 trillion kilometers. Multiply that by 26,000 and the scale exceeds comprehension. The light we see today from Sagittarius. A star began its journey when our earliest human ancestors were just beginning to master stone tools. To measure such distances is not a casual act. It requires precision, patience, and technology that can detect motions so small they would seem imperceptible. And yet astronomers have done it, refining the number again and again with each new generation of instruments. The method is elegant. Measure how fast stars move near the galactic core. Use Newton's laws and Einstein's refinements to calculate the mass required to hold them in orbit. Compare their apparent paths to models and adjust until the numbers align. The result is not only the mass of the black hole, about 4 million suns, but also the distance between us and that heart. From our Orion spur, from our small neighborhood of stars, we are circling the core at 26,000 light-years, making one full revolution every 225 million years. That means in the entire history of complex life on Earth, our solar system has completed only a few galactic orbits. Dinosaurs walked the planet when we were on a different stretch of this path. The first forests grew when we were in yet another. Our orbit is not simply a number. It is a timeline of Earth's story woven into the larger history of the galaxy. The measurement of this distance also tells us about motion. Our Sun, and with it every planet, drifts at an average speed of about 828,000 kilometers per hour relative to the galactic center. That velocity is difficult to imagine. In 1 second, we travel more than 200 kilometers. In 1 year, we cover nearly 1 billion. Yet from Earth's surface, where we measure days in footsteps and seasons in months, this galactic motion is invisible. Only instruments reveal it, only mathematics confirms it. But once you know, every star above takes on a new meaning. They are not fixed jewels. They are fellow travelers, each on their own orbit around the same invisible heart. The question of distance was not settled instantly. Early estimates varied wildly, from 15,000 to 30,000 light-years. Each refinement came with better data, sharper infrared telescopes, longer observations of stellar orbits, more sensitive detectors. By the early 21st century, international teams using observatories like the Very Large Telescope in Chile and the Keck Observatory in Hawaii had narrowed it to the figure we trust today. These observations have been awarded Nobel Prizes because they not only confirmed the existence of Sagittarius A star, but also anchored our cosmic position with unprecedented accuracy. Knowing our distance to the galactic center is more than cartography. It defines the shape and scale of the Milky Way. If we were closer, the galaxy's diameter would be smaller. If we were farther, it would be larger. Our orbit is one data point in the cosmic equation that determines the mass of the galaxy, the distribution of dark matter, and the speed of its rotation. To place Earth precisely is to calibrate the entire map of our galaxy. It is as if by knowing our home address we unlock the structure of the city. There is something poetic in the number itself. 26,000 light-years is not round, not neat. It feels irregular, reminding us that the universe does not conform to human convenience. Yet it also feels intimate. It is a number we can carry, a distance that becomes part of our cosmic biography. We live in the Orion Spur, circling the galactic core, 26,000 light-years from the heart. It is not myth. It is not philosophy. It is measurement, born of starlight and patience. And yet even with this precision, awe remains. To know the distance is not to diminish the mystery. Standing under the night sky, tracing the Milky Way with your eyes, you still see a river of light arcing across the dark. You cannot see Sagittarius a star. You cannot feel the sun's enormous speed, but you can know that all of it is real, that your life is carried on this orbit, that your planet is part of a greater cycle, turning endlessly around a heart of darkness that shapes us all. There is also humility in this discovery. For much of human history, we placed ourselves at the center of Earth, of the solar system, of the universe. Each step of science moved us outward. Earth is not central. The Sun is not central. Even the Milky Way is not unique. To know that we are 26,000 light-years from the core is to embrace that humility fully. We are not at the center of the galaxy, not even near its great bustling arms, but on a quiet spur, circling patiently in the suburbs. Yet from here, life has arisen, civilizations have flourished, and the question of existence has been asked. Our location is not grand, but it is ours. The story of circling the core is a story of perspective. We orbit a black hole we cannot see, at a distance too vast to imagine, at a speed too great to feel. And yet we measure it, we name it, we carry it in our minds. We know our galactic address. 26,000 light-years from Sagittarius, a star, in the Orion Spur, orbiting the Milky Way's heart every 225 million years. That knowledge is a lantern in the dark, a point of orientation in a universe without edges. It tells us that even as we move endlessly, even as we circle a shadow, we can still know where we are. The ground beneath our feet feels steady. The stars above appear fixed, scattered like jewels that have always been and will always remain. Yet this stability is only an illusion crafted by the slowness of cosmic time. In truth, the Sun is not still. It is a traveler, racing through space at hundreds of thousands of kilometers per hour, dragging the Earth and every planet with it on a vast, unending journey. This journey is not around the Earth, not even around the Sun, but around the Milky Way itself. One complete orbit of the galaxy takes about 225 million years, a timescale so immense that in the time it takes to circle once, species rise and fall, continents drift, oceans open and close, and entire ages of life come and go. The Sun's long journey is the story of Earth's motion on the grandest scale. A voyage through spiral arms and interstellar voids, through danger and shelter, through change that humanity can barely comprehend. The orbit of the solar system is not a neat circle, but an elongated path that wobbles and bobs through the galactic disk. At about 26,000 light-years from the Milky Way's center, the Sun completes one revolution in roughly the time it takes for dinosaurs to emerge, thrive, and vanish. Imagine that when the Sun last stood in this exact position on its orbit, there were no humans, no mammals even close to modern form. The world was dominated by reptiles. Pangaea had already fractured into drifting continents, and flowering plants were still in their infancy. That is the scale of a galactic year. All of recorded human history occupies only a fraction of a single step in that orbit, less than the blink of an eye on this timescale. As the solar system drifts through its path, it encounters different regions of the galaxy. Sometimes it passes near spiral arms, where star formation is fierce, where nebulae glow and supernovae erupt, filling the region with radiation and shockwaves. Other times it sails through calmer stretches, inter-arm regions where stars are sparser and space is quieter. These environments matter. Earth's history is punctuated by mass extinctions, climate shifts, and cosmic influences, and some scientists believe these may be linked to the Sun's galactic journey. When we pass through arms, the chances of nearby supernova explosions rise, cosmic rays intensify, and gravitational nudges may disturb comets in the outer solar system, sending icy wanderers inward. The path of the Sun may not dictate every detail of Earth's fate, but it provides the rhythm, the background beat against which life has played its symphony. The solar system does not simply orbit smoothly, it also oscillates up and down through the galactic disk, bobbing above and below the plane like a ship riding a slow cosmic wave. This vertical motion takes tens of millions of years, and as Earth rises and falls, the density of stars around us changes. Some scientists have speculated that these oscillations expose Earth to varying levels of cosmic radiation or gravitational perturbations, perhaps contributing to cycles of extinction or bursts of evolution. While the evidence is debated, the idea itself highlights the deep connection between galactic dynamics and the fragile history of life on Earth. The Sun's journey is not just an astronomical fact. It is a biological backdrop, a theatre in which life evolves under shifting cosmic conditions. Throughout this orbit, the Sun carries its retinue: Mercury, Venus, Earth, Mars, the gas giants, the icy dwarfs, and the vast Oort cloud stretching light-years into space. All of it moves together, bound by gravity, drifting through the galaxy like a fleet of ships tied to a flagship. Around us, other stars drift as well, each with their own planets, their own motions. Over millions of years, neighbors change. Stars that are close today will drift away, new ones will approach. On human timescales, constellations appear eternal. On galactic timescales, they dissolve and reform as the Sun sails on. The familiar patterns in our night sky are temporary sculptures carved by motion, destined to morph beyond recognition long before the Sun completes even a fraction of its orbit. This journey is not without hazards. Spiral arms are not just cradles of creation, they are dangerous neighborhoods filled with massive stars that live fast and die explosively. Passing too near a supernova could bathe Earth in radiation, stripping the ozone layer, damaging ecosystems. A gamma-ray burst within a few thousand light-years could sterilize the surface. Gravitational interactions with nearby stars could disturb the Oort cloud, sending showers of comets into the inner solar system, increasing the chances of impacts. Earth's history bears the scars of such encounters, craters marking collisions, layers of iridium marking extinctions. The Sun's orbit is not a safe circle, but a pilgrimage through hazards and opportunities, through regions that test the resilience of life. Yet it is also a journey of wonder. As the solar system drifts, it passes by nebulae, clusters, and gas clouds. Our telescopes have captured images of brilliant star nurseries like the Eagle Nebula's Pillars of Creation or the Orion Nebula's Glowing Cradle, both within our galactic neighborhood. Though Earth is too far to see these with the naked eye as anything more than smudges, their light reaches us as part of the scenery of our orbit. The journey grants us a changing view of the galaxy, different perspectives over millions of years, though no single human lives long enough to notice. Civilization itself is a blink on this path, but astronomy allows us to imagine the vista, to project what the Sun sees on its long road. The speed of our orbit is staggering, about 828,000 kilometers per hour. At that rate, the solar system travels around 230 million kilometers every day, roughly the distance from the Sun to Mars. In 1 year, we drift billions of kilometers along our galactic path, and yet this enormous speed is unfelt. Gravity carries everything together, so we sense no wind, no rush, no acceleration. The journey is silent, steady, invisible to the senses but undeniable to the instruments that measure it. It is a reminder that the greatest motions in our lives are the ones we do not feel. That Earth is always in motion, spinning daily, orbiting the Sun yearly, and circling the galaxy on timescales beyond human imagination. When we place the Sun's orbit in context, the fragility of human history is clear. Civilization, from its first cities to its present age of technology, occupies less than 1/10,000th of a galactic year. The entire span of Homo sapiens is less than a single step on the orbit. Dinosaurs dominated Earth for 160 million years, roughly 2/3 of a galactic year, before vanishing. The solar system has circled the galaxy only about 20 times since it first formed 4.6 billion years ago. Each orbit has seen entire ages of Earth rise and pass away. Our species is new, our history a flicker, our presence a momentary detail in the Sun's long road. And yet, the very fact that we can know this is extraordinary. From a small planet orbiting a modest star, we have built instruments that measure the motions of distant stars, that trace the Sun's orbit, that calculate our speed and distance with precision. We have charted the course of our solar system through the galaxy and placed ourselves in context. We know we are 26,000 light-years from the core, traveling on a spur of the Milky Way, moving fast enough to circle the galaxy every 225 million years. This knowledge is both humbling and empowering. It reminds us of our smallness, but it also affirms our capacity to understand, to measure, to glimpse the shape of the universe even while trapped within it. The Sun's long journey is not a path we chose. It is the inheritance of gravity, the destiny of a star born in the Orion spur. But in recognizing it, we gain a new perspective. We are not still. We are not fixed. We are part of a motion so vast it makes human history seem like a flicker, yet that motion is part of what makes life possible. The Sun's orbit shelters us in quiet neighborhoods, challenges us with dangerous arms, and gives us the changing sky that has inspired stories, myths, and science. To live on Earth is to be a passenger on this voyage, to ride the solar system as it sails endlessly through the galaxy, circling a core we cannot see, but whose pull we feel every second. At night, when you look up at the stars, you are looking not at fixed points but at fellow travelers. They too are orbiting the galaxy, moving in their own paths. Constellations are temporary alignments, neighbors for a time on the road, destined to drift apart. The Milky Way itself, the river of light, is the collective glow of billions of fellow voyagers, all circling the same unseen heart. The sun's long journey is not solitary. It is part of a grand migration of stars, a cosmic dance in which every participant moves, none stand still, and all are bound together by the pull of gravity. We live in a galaxy alive with motion. The sun carries us on its path, circling the core, completing revolutions we will never see finished. The scale is immense, the timescales unimaginable, but the meaning is clear. We are travelers, part of a solar system on an eternal road. To know this is to know that Earth is not just a planet in space, but a ship in motion, voyaging through arms and voids, through creation and destruction, through the endless spiral of the Milky Way. The Milky Way is not alone. To the naked eye on a clear night in the southern hemisphere, two ghostly smudges appear in the sky. They are not clouds of weather, but clouds of stars. The large and small Magellanic Clouds, nearby dwarf galaxies trailing alongside our own. To early navigators, they were guideposts in the dark seas. To storytellers, they were marks of mystery. To modern astronomy, they are neighbors, companions in the galaxy's long journey through the cosmos. They remind us that our Milky Way is not static, but alive, tugged by gravity, merging, reshaping. Our galaxy is part of a dynamic system, a family of satellites, streams and fragments, constantly moving in the dark. The Magellanic Clouds are small compared to the Milky Way. The large Magellanic Cloud spans about 14,000 light-years, less than a seventh the size of our galaxy, and the small Magellanic Cloud is even smaller. Yet both are rich in stars, gas and nebulae, forming new suns at a furious pace. The Tarantula Nebula, within the Large Magellanic Cloud, is one of the most active star factories in the local universe, birthing clusters and massive stars whose light reaches us across 160,000 light-years. When we look at them through telescopes, we are peering into bustling cosmic nurseries, reminders that even small galaxies can burn with vitality. These galaxies are not merely drifting nearby, they are bound to the Milky Way, locked in a slow gravitational dance. Their motions suggest they are either orbiting us or falling into us for the first time, depending on how far back the story is traced. Streams of gas and stars trail behind them, evidence of the Milky Way's pull tearing material from their bodies. This Magellanic stream stretches across the sky, a ribbon of hydrogen wrapping halfway around the galaxy, invisible to human eyes but clear in radio maps. It is a signature of interaction, proof that our galaxy is not isolated, but always shaping and reshaping itself through encounters with its neighbors. And the Magellanic Clouds are not the only companions. Dozens of dwarf galaxies circle the Milky Way like moths around a lantern. Some, like the Sagittarius dwarf spheroidal galaxy, are so close they are being pulled apart before our eyes. Streams of its stars stretch across the sky, wrapping around the Milky Way like tidal scars. These stellar streams are the relics of galactic cannibalism, trails of light left behind as our galaxy consumes smaller ones. The Milky Way's halo is laced with these streams, ghostly evidence of past mergers, each one telling the story of a galaxy swallowed, of stars ripped from their homes and folded into our own. This process is not unique. Across the universe, galaxies grow by merging. Larger galaxies consume smaller ones, their stars incorporated, their gas feeding new generations. The Milky Way itself is a product of such collisions, a survivor and beneficiary of countless mergers. Our spiral arms, our bulge, even our halo are shaped by these events. To look at the Magellanic Clouds and nearby dwarfs is to see echoes of our own history, a glimpse into the process by which galaxies evolve. We are not fixed structures, but organisms in cosmic time, always changing, always feeding, always being fed upon. The dynamism of these interactions reshapes the way we think of Earth's place. Our solar system is not just orbiting a black hole at the center of the galaxy, not just circling in the Orion Spur. It is also part of a galaxy in motion, tugged by companions, shedding streams, destined one day to collide with larger neighbors. Earth's address is not static. It is a moving coordinate in a system that grows and shifts. To say we live in the Milky Way is to say we live in a galaxy with a family, a web of neighbors and fragments surrounding it, bound by gravity in a dance that spans billions of years. For stargazers, the Magellanic Clouds are among the most haunting sights in the sky. They are diffuse, delicate, like spilled light on black velvet. Through binoculars, they resolve into stars, clusters, nebulae. They feel close, intimate, even though they are 160,000 and 200,000 light-years away. They remind us that galaxies are not distant abstractions. They can be seen with the naked eye, their light reaching us across unimaginable distances. They are neighbors we can greet directly, companions whose presence has been known since long before astronomy gave them names. Instruments reveal more. Radio telescopes trace the streams of gas pouring from them, linking them like bridges to the Milky Way. Infrared observations pierce their dust, uncovering young stars in the act of ignition. X-ray detectors capture the flare of supernova remnants glowing in their arms. These galaxies are alive, not fossils. They are laboratories for understanding star birth, death, and the cycles that shape galaxies of all sizes. They also hint at the future. One day, perhaps billions of years from now, the Magellanic Clouds may be fully absorbed into the Milky Way, their stars scattering across our spiral disk, their histories merged with ours. The dwarf galaxies are harder to see. Some are faint smudges, discovered only in recent decades through careful sky surveys. Yet their impact is no less real. The Sagittarius dwarf galaxy is already in the process of being torn apart, its stars stretched into a vast stream that loops around us. Other dwarfs lurk like shadows, their motions betraying their presence. They are reminders that the Milky Way's outskirts are crowded, its halo a graveyard of cannibalized galaxies, its present shaped by a long history of consumption. This merging is not violent in the sense of sudden explosions. It is slow, patient, a process stretched across hundreds of millions of years. Stars do not crash into each other, they are too far apart. Instead, gravity pulls galaxies together, distorts them, stretches them, and eventually blends them. The Magellanic Clouds are being stretched even now, their gas siphoned into streams, their stars tugged by our pull. Their presence is temporary, their future already written in the language of merger. To live in the Milky Way is to live in a galaxy that is not done growing, not done changing, not done absorbing. This knowledge redefines home. The Milky Way is not a static island, but a dynamic system, part of a larger web of galaxies. Our nearest large neighbor, Andromeda, is on a collision course, set to merge with us in about 4 billion years. The Magellanic Clouds, the Sagittarius dwarf, the faint companions, these are all part of the same story. Galaxies caught in gravity's net, blending into something larger. Earth is not just circling the galactic center. It is part of a solar system carried on a galaxy that is itself evolving, reshaping, merging. We are travelers in a caravan, not solitary wanderers. To stand under the southern hemisphere's sky and see the Magellanic Clouds is to feel this truth in your bones. They are not abstract. They are visible, direct, glowing softly. They are neighbors in the dark, reminders that the galaxy is not singular, that the universe is crowded, that our home is dynamic. To see them is to see the Milky Way's companions, its evidence of growth, its testimony of interaction. They whisper that the story of Earth is tied not just to the sun and the galaxy's core, but to the wider dance of galaxies, a story of tides, streams and mergers written across billions of years. The Sun's journey through the Milky Way carries us not only around the core, but also through this dynamic system of neighbors. The Magellanic Clouds move with us, the dwarf galaxies tug at us, the streams lace the sky with memory. We are not orbiting in emptiness. We are embedded in a structure, alive with motion. Our location in the galaxy is not a fixed dot, but a shifting node in a cosmic web. We are neighbors in the dark, part of a family bound by gravity, traveling together through the vastness of the universe. When we stand under a clear night sky and let our eyes adjust to the dark, the Milky Way appears as a pale river of light stretching from horizon to horizon. It looks eternal, unchanging, a silent canopy above us. Yet the truth that astronomy has uncovered is at once humbling and wondrous. The stars are not fixed, the galaxy is not still, and Earth itself is not at the center of anything. We live in motion, carried on a solar system that circles a black hole 26,000 light-years away, drifting on a minor spur of a spiral arm in a galaxy that is only one among billions. Our location is not privileged. It is not marked on any cosmic map as central or supreme. It is ordinary, and in that ordinariness lies a beauty more profound than any myth of centrality could provide. For much of human history, people believed otherwise. Ancient cosmologies placed Earth at the center of the universe. The sun, the moon, the stars, all of them revolved around us, or so it seemed. Even after Copernicus and Galileo shifted the center to the sun, many still imagined the Milky Way as the whole of existence, with our star somewhere near its heart. But science, in its patient, relentless way, peeled back each illusion. Herschel mapped the stars and revealed the galaxy's shape. Shapley measured the clusters and placed the sun in its outskirts. Hubble turned his telescope to Andromeda and showed that the Milky Way was just one galaxy in an ocean of galaxies. Radio astronomy pierced the dust and revealed spiral arms, confirming that we live not in the center, but in the Orion Spur, a side street between grander lanes. Infrared and radio instruments confirmed a black hole at the galactic core, a monster we circle without ever approaching. Step by step, the dream of centrality was stripped away, leaving something quieter, smaller, but infinitely more vast. The irony is that by becoming smaller, we became part of something larger. To know we are not central is to know we belong to the whole. Earth is not the axis of the universe, but it is a participant in the Milky Way's dance. The Milky Way is not the universe, but it is part of the cosmic web. We are not supreme, but we are included. And to be included in a spiral galaxy of 400 billion stars, itself a member of a local group with Andromeda and dozens of dwarfs, itself part of filaments stretching across the universe, is a belonging beyond anything myth ever promised. It is a belonging not of hierarchy, but of connection. Our location is a vantage point, not a throne. From here, on a minor spur, we can look inward and see the dense star fields of Sagittarius, glowing with the light of the galactic bulge. We can look outward and see the sparser regions toward Perseus. We can see Andromeda with the naked eye, faint but present, proof of another galaxy like ours. We can see the Magellanic Clouds from the southern hemisphere, companions bound to us. From this perch, we can map the universe, measure its expansion, and detect the whispers of the cosmic microwave background. We can do all this precisely because we are not blinded by centrality. We are in a quiet neighborhood, far from the noise of the core, with a clear view outward. Our insignificance has given us clarity. The ordinariness of Earth's location is also a gift. Life thrives here not in spite of our galactic address, but because of it. Near the galactic center, radiation is fierce, supernovae erupt often, and gravitational chaos rules. Far in the outskirts, heavy elements are scarce, making it harder for rocky planets to form. But here, in the Orion Spur, the balance is just right. We have metals forged in generations of stars, yet we are distant from the most destructive events. The Milky Way's habitable zone is not a guarantee, but it is a probability, and Earth lies within it. Our ordinary place is, in fact, unusually favorable. It is not central, but it is enough. As the Sun carries us on its orbit around the galaxy, we drift through arms and voids, pass by nebulae and clusters, rise and fall above the galactic plane. The stars we see at night are fellow travelers, each on their own paths around the same invisible heart. The constellations we know are temporary alignments, soon to dissolve and reform as motion carries them onward. The Milky Way itself is dynamic, interacting with dwarfs, stretching streams across the sky, destined one day to merge with Andromeda into a new galaxy altogether. Earth's address is not fixed. It is written in motion, in orbits, in collisions and mergers that shape the future. To know our place is not only to know where we are, but to know that we are always changing. Yet in this shifting, expanding, humbling universe, we are capable of awareness. From a small rocky world orbiting an ordinary star, we have pieced together a map of the galaxy we cannot see from above. We have measured our distance from the core, our speed through space, our orbit's length. We have detected black holes, mapped spiral arms, and discovered that galaxies beyond our own fill the sky. We have sent machines beyond the solar system, carrying whispers of humanity into interstellar space. We have looked up and understood, however imperfectly, the context of our existence. That act of understanding is itself extraordinary. To close the story of Earth's location is not to say we are central, nor to say we are irrelevant. It is to say we are beautifully ordinary. Our planet orbits a star that is one of hundreds of billions. Our star circles a galactic core in a disk that is one of billions. Our galaxy drifts in a cosmic web without center, without edge. And yet, here, on this small planet, awareness has bloomed. Consciousness has emerged, asking the very question, where are we? The answer is humbling, but it is also profound. We are not the center, but we are part of the whole. To stand under the Milky Way is to feel this truth. The river of stars arches above, its light ancient, its patterns temporary. You are looking into the past, into the collective glow of billions of suns, into the structure of a galaxy that holds us but does not privilege us. You are seeing from the inside what no one can see from the outside. You are both small and infinite, a fragment in context, a consciousness located not at the heart, but in the ordinary lanes of the spiral. That is not a diminishment. That is a gift. Earth's home in context is not central, not marked, not destined for eternity. But it is real. It is enough. In the quiet suburbs of the Milky Way, 26,000 light-years from the core, orbiting patiently in the Orion Spur, life has flourished and asked questions. That ordinariness is beautiful because it means we belong, not at the center, but within, not above, but among, not special, but luminous in our ability to see and to wonder. Our home in context is this: an ordinary planet, in an ordinary spur, in a spiral galaxy among billions, and in that ordinariness, a miracle of awareness that can look up at the stars and know where it is.